Hello everyone. On this video I will explain how to solve the transportation problem. So I will be using example number 3 in order to explain how to solve the transportation problem. So the Sunray Transport Company ships truckloads of grain from 3 silos to 4 mills. The supply is in truckloads and the demand is also in truckloads, together with the unit transportation costs per truckloads on the different routes are summarized in the transportation model in table 2. Okay, the unit transportation cost, the CIJ, it is in the northeast corner of each box, are in $100. The model seeks the minimum cost of shipping between the silo and the mill. Okay. So this is the model. So we have three sources and we have four destinations. So the cost of sending grain from silo 1 to mill 1 is 10, from silo 1 to mill 2 is 2, and so on. And the last one, which is 18, that is the cost of sending grain from silo number 3 to mill number 4. So the silos are the supply and mills require demands. And the first thing that we need to check is the total supply equal the total demand. So before doing that, I will copy the table into other window. Okay, so this is the problem. So the first thing that I need to check is the total supply, and the total supply is 15 plus 25, that is 40, plus 10, that is 50, and then total demand, and that is equal 5 plus 15, 20, 20 plus 15 and plus 15, and that is 50. So the total supply equals total demand. Then we can solve this problem because the problem is balanced. So it is balanced. Okay. Now, to solve the transportation problem, there are two steps. In solving the transportation problem. Step 1, finding the BFS. And step 2, the transportation algorithm to find the optimum solution. Okay, in this class, to find the BFS, the method that I will use is the Vogel approximation method, or the VAM. Okay, now we will start step 1, finding the BFS. BFS means the basic feasible solution, by using the Vogel approximation method. So step 1, finding the BFS, the basic feasible solution, using VAM, Vogel approximation method. Okay, I'm gonna copy this table down. Okay. Okay, in Vogel approximation method, the first thing that we need to do is to find for each row or column. So I mean, we need to determine a penalty by subtracting the smallest unit cost element in the row or column from the next smallest unit cost element in the same row or column. So let's do that. So row 1, the smallest cost is 2, and the next smallest cost is 10. So the penalty is 10 minus 2, and that is 8. For row number 2, so it must be 9 as 9 minus 7. So the penalty is 2. Row number 3, the smallest is 4, the next smallest is 14. So the penalty is 10. For column 1, the smallest is 4, the next smallest is 10, so the penalty is 6. Column 2, it is 5. Column 3, and as 9 and 16, that is 7. And column 4, 11 and 18, and that is 9. So now we have all the penalties. And the next thing that we need to do is to find the biggest penalty. And the biggest penalty is 10. So this is the biggest penalty. It is 10. Then the thing that we need to do to identify the in the row with the biggest penalty, we need to find what cell has the smallest cost. And this is the cell with the smallest cost, that is 4. And then we need to allocate as much as possible our supply to this cell. So we're gonna put some number over here. So the supply is 10, but the demand is only 5. So we can only allocate 5. Okay, so it's 5. And I'm gonna make room a little bit here. And also here, I'm gonna make some rooms for me to write. Okay. That's too far. Okay. So now, so from 10, I allocate 5. So I have 5 left over here. Okay. So the demand is 5. I give 5. So I satisfy the demand. So this, now I have 0 over here. So column 1, it has a 0 demand. So I fulfill it. So now I can cross column number 1. Okay. And then the next thing that I need to do, I will repeat this step by using the same method. So see, now we need to get the penalty for row number 1. Now it is 11 and 2, so the penalty is 9. It is 9 and 7 right now. Is 2, the penalty. Row number 3, it is 14 and 18, and that is 2. So we are done with column number 1. So it stays the same. For column number 2, it is 5. 7 and 9. We need to identify the the biggest penalty. So we have 9 and 9 over here, so they are the same. So we will choose anything we want. So for this problem, I will choose row number 1. So I have 15 over here, and I need to find the smallest cost. It is 2, that is the smallest cost. So I'm gonna put, so the supply is 15, the demand is 15, so I can allocate 15. So 15. So 15, I give 15, so it is now 0. Okay. And here also 15, the demand, and I give 15, so we have 0 left. So we have 2 0, 0 in row 1 and 0 in column 2. We need to cross one of them. So we have, if we have 2 0, so we just need to cross one of them. So I will cross column number 2. You can also cross row number 1, it doesn't matter. Okay. Okay. Now, again, I need to find the penalty. So it is now 11 and 20, that is 9. 9 and 20, 11. And 18 and 16, that is 2, the penalty. So it stays the same. 7 and 9. Okay, the largest one is 11. So I need to allocate 25 to column 3 or column number 4. So the smallest cost is 9. So we have demand 15, so I can only allocate 15. So 15 over here. So demand 15, I give 15, so I fulfill it. 25, I give 15, so I have 10 left. Okay. So it is 0, column number 2, column number 3, sorry. And now I will cross it. Okay. Okay, then I will repeat the same step. So I just have 11 over here. It is the only one. 20 and 18. Okay. And here I have 9. Okay. So the largest penalty is 20, so I need to allocate. So I have 10 over here and I have 15 over here. So only 10 that I can allocate. So this is the only cell that I have. So 10. So I have 10, I give 10. So I have 0 left. Okay. And also it is 15, I give 10. So I have 5 left. Okay. So I will cross row number 2 because I satisfy it. Okay. Now we repeat the same thing. So here I have 11, so I fulfill this one, and here I have 18, and over here I have 18 and 11, and that is only 7. Okay, so 18 is the largest one, so I have 5. It is 5, so I can allocate 5. Okay, so I will fulfill this one. I have 5, I give 5, so I have 0. And they ask for 5 more, but I give them 5, so there is no more, so it's 0. So I have 2 0 over here, then I need to choose which one that I need to cross out. So this is very important. So the BFS, the number of BFS that we need to have is number of row plus number of column, and in this minus 1. Okay, and in this case that will be 3 plus 4, 3 plus 4 minus 1, that is equal 6. So we need to have 6 variable as our basic feasible solution, and so far we have 1, 2, 3, 4, 5. So we have 5. So we need one more. Okay, so if I cross this column, so every cells are crossed out. So that means I'm done. But if I do that, then I will just have 5 basic feasible solution. But if I cross out row number 3, I still have one cell uncrossed out, and that will be the candidate for the 6 BFS. So the better thing that we can do is to cross out row number 3. Okay. Now we have the last cell that we have not crossed out, which is cell 1, 4. So the supply is 0 and the demand is 0, so I can allocate 0. Okay. Then 0, I give 0, then I have 0 left. The demand is 0, I give 0, and I have 0 left. Then I can cross out row number 1. Okay, so see, now every cell is crossed out, so we are done. Okay, so I repeat, the number of BFS that we need to have is the number of row plus the number of column minus 1. So now our basic feasible solution, or our basic variable, is x12 with the value of 15, x14 with the value of 0, x23 with the value of 15, x24 with the value of 10, x31 with the value of 5, x34 with the value of 4. So that's our basis. So basis are basics are x12 equal 15, x14 equal 0, x23 equal 15, x24 equal 10, x31 equal 5, and x34 equal 5. Okay, then the other variable are x11, x13, and so on. Their value are 0, and they are non-basics. Okay, so this is the step 1. So this is just the step 1. We are not done yet. We need to do step 2, which is we need to run the transportation algorithm. So in order to do step 2, I need the table that I produced from step 1. So the thing that I'm gonna do, I'm gonna copy the original table because, okay, okay, okay. I need a larger space. Okay, I think that is enough. So I need this table again. Okay, I'm gonna copy it down. So this is it, the table that we need. Okay, and the base is 15 over here, 0 over here, 15, 10, and 5. I need to double check. 1, 2, 3, 4, 5. So 1 left. So 5 over here. So here we're gonna start step 2. Step 2, run the transportation algorithm to find the optimal solution. Okay, so there are two very simple equations that we need to use. So the equations are, so ui plus vj must be equal cij, and this equation is for basics variable. Okay, and the next equation is ui plus vj minus cij, and this equation is for non-basic. Okay, so we start from the basic variable. So the u is for row, vj that is for the column. So we're gonna have u1, u2, u3. We're gonna have v1, v2, v3, and v4. Okay, I need some room over here. Okay, so we're gonna have over here u1, and u1 will always be 0. u2 we do not know yet its value. u3 we do not know yet its value. v1, v2, v3, and v4. Okay, now we know that we need to have ui plus vj equals cij. The cij is the cost 10, 2, 11, 9, 7, and so on and so forth. So we have u1 is 0, and we have 2 over here. So u plus v must be equal to. So u1 is 0, so v2 must be equal to. Okay, so we have v2, and we cannot So we can calculate V4. So U1 is 0, V4 is 4, the cost is 11. So 0 plus what equal 11? So V4 is 11. Okay. Now, I cannot have U2 from V3 because I do not know V3, but I can have U2 from this V4. So I don't know U2. V4 is 11, C is 20. So U2 plus 11 equal 20. So U2 must be 9. So I know U2, then I can calculate V3. 9 plus what equal 9, so that is 0. So V3 is 0. And then the next basis, so 5. So I do not know V1. So I cannot find U3 from there, but I know V4, so I can find U3. So 11 plus what equal 18, and that's equal 7. Okay, I know U3, then I can have V1. So 7 plus 1 equal 4, and that is minus 3. Okay. So we are done for the basis variable. Now we're gonna calculate Ui plus Vj minus Cij for non-basic. Okay. So 0 plus minus 3 minus 10. So that is minus 13. I'm gonna put it over here. I'm gonna make it smaller. So that's minus 13. Okay. And this one, 0 plus 0 is 0. Minus 20, minus 20. Okay. This is basis, so this is non-basis also. 9 plus minus 3, 6 minus 12 minus 6. Okay, this is non-basic. 9 plus 2, 11 minus 7, 4. Okay, so here I have 7. 7 plus 2, 9 minus 14 minus 5. 7 plus 0, 7 minus 16, and it is minus 9. Okay. Now, when we have all the value, when we have all Ui plus Vj minus Cij, which is this value, if all of them are negative or 0, then we will reach optimality. So I need to write it down here. When Ui plus Vj minus Cij for all non-basic, okay, if they are less than or equal 0, then optimum. Okay, if no, find the most positive or the largest Ui plus Vj minus Cij and the corresponding variable is the entering variable. Okay. So in this example, this is minus, 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 but this one is positive. So we are not reaching optimality yet. So x22, enter basis. Okay. Now the value of x22 is 0, so we will increase the value of x22. How much we will increase it, we do not know. So let's assume that we increase it as t. Okay. Now, because we have x22 as the entering variable, then we need to find the leaving variable. So in order to find the leaving variable, we need to make a loop. So what is it? We need to make loop. Okay. Okay. From t, and then so the loop start from t and ends at t also. Okay. So the loop must be following the row and the column. So you cannot make a loop diagonally like this. So you must following the row and the column. And one more thing, the loop must be balanced. Okay? So here we have t over here. So with the loop we must pass the basic variable because we want to find the leaving variable. So when creating the loop, we must pass a basic variable. Okay. Okay. So we have t over here. Okay. To make a loop. Okay. If I stop here, so I need to put minus t in order to make it balanced, because minus t and t, it is 0, so it is balanced. But with minus t over here, I cannot go up or I cannot go down. Okay. So that will not be balanced because there is no plus t in column 3 that I can put in order to make the minus t over here gone. Okay, so I will pass that one. So I will go here. So with 10 over here, I can go up or I can go down. So I can put minus t over here. So the t and minus t, it is balanced, it is 0 right now. So I'm gonna put minus t over here, minus t. See, I need to have this minus t gone. So I can go down and put plus t over here, and then I can go here and put minus t over here. But when I have minus t over here, there is nothing that there is no cells or basic variable that I have to put plus t. So I will not go down, but I will go up. Okay, I will go up and I put plus t over here. So minus t and plus t, it is gone. And then I'm gonna go here and I'm gonna put minus t in order to make this plus t gone and this t gone. And then after that I go down. Then I have that loop, and it is a balanced loop. So t minus t gone, minus t and t, that is 0, plus t and minus t, that is 0, minus t and t, and that is 0. So this is the loop. So from the loop, I can determine the value of t. So from x to 4, I know that 10 minus t must be bigger than or equal 0. Okay, here 0 plus t must be bigger or equal 0 because every variable must be positive, and 15 minus t must be bigger or equal to 0. Okay, that's what I have from the basic variable that I have now. So from the first one, this means that t less than or equal 10. Okay. From the second one, that means t bigger than or equal 0, right? And from the last one, that means t less than or equal 15. Among those three, we know that uh, the first one gives us more limitation because it said that t must be less than or equal 10. When we choose t less than or equal 15, so we will violate the first one because it said t at most is 10. So as a conclusion, because this is the most the most stringent one, so as the conclusion, the highest value of t that we can have, it is 10. So t is 10. So the value t equal 10, we get it from, so this is x to 4, and as a conclusion, x to 4 leaf basis. Okay, so now I need to update my table. Okay, I'm gonna copy this table again. Okay, okay, okay. So what I have, so the t is 10, so it's 10. Now it is become basis 10. So 15 stay the same. Okay, so x to 4 leaving basis, so its value now 0 because it is non-basis. We do not put any number on it. So this is 10, 0 plus t is 10. So 15 minus 10, 15 minus t, that is 5. We have 5 over here, and we also have 5 over here. Let's double check how many of them we have. 1, 2, 3, 4, 5, 6. So we are okay. Now we need to repeat the same thing. We need to use this equation again. Okay. So we need to calculate u and v. So we have u1 equals 0. It is always 0. u1, u2, u3, v1, v2, v3, and v4. Okay, so u plus v equals Cij, that is for basic variable. So u1 is 0, so 0 plus 1 equal 2, and that is 2. 0 plus 1 equal 11, that is 11. Okay, for u2, so I don't know u2, v2 is 2, 2 plus 1 equals 7, that is 5. Okay, so I have 5 over here. 5 plus 1 equal 9, so that is 4. So v3 equal 4. Okay, u3, I don't know, this is 11, 18, so 11 plus 1 equal 18, and that is 7. Okay, and then I have 7 over here. 7 plus 1 equal 4, and that is minus 3. Okay. Okay, now I need to calculate ui plus vj minus cij for the non-basic variable. So 0 plus 3 minus 3 minus 10 minus 13. Okay, it's non-basic. So this one 0 plus 4 minus 20 minus 16. And 5 plus minus 3, that is 2. 2 minus 12 minus 10. Basic, so we do not do for them. 5 plus 11, 16 minus 20 minus 4. Okay, and this one 7 plus 2, 9 minus 14 minus 5. And 7 plus 4, 11 minus 16, that is minus 5. Now C, now we have all ui plus vj minus cij for the non-basic, minus 13, minus 16, minus 10, minus 4, minus 5, and minus 5. So all ui plus vj minus cij is less than equal 0 for all non-basic variables. Okay, so when this happen, so we need to stop. We have optimality. Okay, now so we stop here. We have optimal, we have the optimal solution now. So what are the solution? So the solution is, so x1 2 equal 5, x1 4 equal 10, and then x2 2 equal 10, and then x2 3 equal 15, and then x3 1 equal 5, and then x3 4 equal 5. Other variable, they are non-basic and their value are 0. So x11 equals 0, x13 equals 0, x21 equals 0, x24 equals 0, x32 equals 0, and x33 equals 0. Now what is the value of this is the, so because it is optimal solution, I need to put star over here. Okay, just to indicate them as the optimal solution. And what is the value of z star? So the total cost will be 5 plus 2, 5 times 2 plus 11, 10 times 11 plus 10 times 7 plus 15 times 9 plus 5 times 4 plus 5 times 18, and the total must be 435. Okay, is that 435? Yeah, that is 435. Okay, so what is the conclusion? The conclusion is that we need to send 5 truck loads from silo number 1, from silo number 1 to mill number 2. We need to send 10 truck loads from silo number 1 to mill number 4. We need to send 10 truck loads from silo number 2 to mill number 2, 15 from silo number 2 to mill number 3, 5 from silo number 7 to mill number 1, and 5 truck loads from from silo number 3 to mill number 4. And I think this is it, the transportation algorithm. And in the next video I will explain how to deal with the uh, unbalanced transportation table, meaning that the total supply and the total demand, they are not equal. And thank you very much.